Solving for a missing variable in an equation is much like a balance. So we want to keep this equation balanced, and to do that, we need to make sure that we do the same things to both sides of the equation so it stays balanced. Think of it as a teeter-totter at a playground. If you add a brick to one side, in order to keep that teeter-totter balanced, you need to add a brick to the other side. So what we do to one side, we're going to do to the other. In this first example, to solve for that missing variable of x, we first need to get rid of the 3. We are actually going to do the opposite of order of operations, which is PEMDAS, because we are undoing those operations, so we need to do them in the reverse order. So PEMDAS backwards is something like this. So we're going to undo our addition and subtraction first. Then we are going to undo our division and multiplication, then third our exponents, and then lastly our parentheses. So that's how we're going to follow those order of operations. When we're undoing them, we're going to undo them in the reverse order. So in this first example, I'm first going to get rid of that 3, which it is actually a positive 3. I just don't choose to write that there. So to undo that, I'm going to do the inverse operation, and that is to subtract 3 from both sides. So you'll see now that 3 minus 3 is 0, and that leaves me with a negative 7x. Don't forget about this negative that's in front of that 7x. We need to keep that value negative. Then I'm going to bring my equal sign straight down, and then 11 minus 3 is 8. And then lastly, I need to undo my multiplication. This is saying negative 7 times x. It's not saying x minus 7, so I'm not going to add 7 to both sides. It's saying negative 7 times x. So the inverse operation of that is to divide both sides by negative 7, and I'm going to use my fraction bar to represent that division. These two numbers have no common factors, so I'm going to keep my answer as a simplified fraction, even if it is an improper fraction. So my solution to this equation is negative 8/7. That means that I would be able to take this value and plug in for x, and it would create a true balanced equation where I have the same value on the left side of my equal sign as on the right. In this next example, the first step that we need to do before we can do any inverse operations is the distributive property. So I'm going to distribute this negative 2 to both things inside that parentheses. Distribution is a multiplication because that is saying negative 2 times everything in that parentheses. So each piece needs to get multiplied by negative 2. Negative 2 times 2y is negative 4y, and a negative 2 times a negative 6 turns to a positive 12. Negative times a negative is a positive. And then I still have an equal to 36. Now I can start using my inverse operations. Once I've done that distributive property, this is now a two-step equation to solve. Once again, I'm going to undo my addition before I undo my multiplication and subtract 12 from both sides. 12 minus 12 is 0, so I don't need to write that anymore. I'm left with negative 4y equals 24. And then once again, this is saying negative 4 times y. Not subtraction here, this is multiplication. So I'm going to divide both sides by negative 4. Now remember, this cancels out on the left-hand side because negative 4 divided by negative 4 is 1, and 1 times y is just y. And 24 divided by negative 4 is negative 6. In this multi-step equation, to solve for that missing variable of x, I have variables on both sides. So I need to move them to the same side. I cannot just combine that negative 8x and 4x because they're on opposite sides of the equal sign. A little trick is if you move them to the side where there are more of them, then they will stay positive. So positive 4x is greater than negative 8x, so I'm going to move my x's to the right-hand side by using inverse operations. So since I want to move the 8 and the x together, I don't want to undo that multiplication. I'm going to use addition to move it to the opposite side. Once again, what I do to one side, I must do to the other. Negative 8x plus 8x, that's 0, so I don't need to write that. I still have a 7 on this left-hand side, an equal sign, and 4x plus 8x. Those are like terms. I can combine them. That gives me 12x, and I still have a minus 17. Now, since I have done that first step of being able to move the variables to the same side and combine those like terms, I'm now left with a two-step equation here. So I'm going to use inverse operations, And my first inverse operation is to add 17 to both sides. And 7 plus 17 is 24. And negative 17 plus 17 is 0, so I no longer need to write that. And I still have a positive 12x on this right-hand side. Then I need to undo my multiplication. Instead of multiplying by 12, I'm going to divide both sides by 12. Once again, 12 divided by 12 turns into 1. 1 times x is just x. And this right here is actually saying 24 divided by 12. 24 divided by 12 is exactly 2. Or if you think about simplifying this fraction, you could take a common factor of 12 out of both, and that would be 2 over 1, which is the same thing as 2. In this multi-step equation, I'm able to combine these two variables right here. I can combine them because they're both the same term, they're both m terms, and since they're on the same side of the equal sign, I do not need to use inverse operations. I use inverse operations to move things to opposite sides. These are not on opposite sides, so I don't need to use inverse operations. So as I read that, 9m minus 3m, I'm just going to combine those like terms. That's the same thing as 6m. I'm not changing this equation, I'm just choosing to write it in another way, in a simplified way. I still have a 10 plus 6m and an equal to 15, and this is a positive 6m, so I'm going to put a plus sign in between those two terms. And now I have variables on opposite sides, so I'm going to move them to the same side using inverse operations. Once again, I'm going to use that subtraction. I don't want to break up that multiplication because I want to keep the 6 and the m together for right now. Positive 6n minus 6m is 0, and as you can see, our variables are canceling out on both sides, and what we're left with is 10 equals 15. Now, we all know that this statement is not true. This is a false statement. So when I have my variables cancel out from both sides and I'm left with a false statement, I know that this will never be true. And since this will never be true, there's no solution to this equation. There's no value that I would be able to plug in into this original equation for this value of m that would give me a true balanced equation. There's no numerical value I can plug in and get the same value on the left as I do on the right. So our answer is no solution. In this next example, I'm going to first do the distributive property. I'm going to distribute this 3 to both terms inside the parentheses. 3 times y is just simply 3y, and 3 times a positive 1 is a positive 3. Notice how I did not distribute to this minus 5. He is not a part of the group, so he's not inside that parentheses. I'm not going to distribute the 3 to the negative 5. So I'm just going to bring him along and copy him down along with my equal to 3y minus 2. Now, once again, I have variables on opposite sides, so I'm going to use opposite operations to combine them. I'm using that subtraction to move it to the opposite side because I want to keep the 3 and the y together, so not division. 3y minus 3y is 0. Once again, we see that my variables are canceling out on both sides. But something a little differently happens with this example. 3 minus 5 is a negative 2. This time, I'm left with a true statement. So when my variables cancel out and I'm left with a true statement, I know that this is always true. Negative 2 will always equal negative 2. So when you have your variables cancel out on both sides and you're left with a true equation, a true statement that will always be true, then your answer is infinite solutions. So there are an infinite amount of numerical values I could plug up in here for y, where I would get a true equation on the left and a true equation on the right. There's not just one solution. There are multiple answers that would work for that equation.